In this lesson, we're going to be looking at the characteristics of quadratic relations. Specifically, we're going to be looking at the characteristics of the graphs of quadratic relations, and those graphs are known as parabolas. And so we're going to be, when we talk about characteristics, we're going to be talking about those two interchangeably when we talk about the characteristic of a quadratic relation. Sometimes you'll hear it referred to as the characteristic of a parabola or vice versa. You can also see I've made a notation here that there's a handout that goes along with this note that has a lot of this information filled in advance to save some of the tedious note taking here. Let's take a quick look at each of these points. So first of all, the vertex, quite possibly the most important characteristic of a parabola. It represents the highest or lowest. Sometimes that will be referred to as the maximum or the minimum. So the highest or lowest point, or the max min point on the parabola, and its coordinates will be referred to as hk. I want you to understand that's still x and y. That's still an x coordinate and a y coordinate. H and k are just the symbols that we typically introduce to refer to these. Now don't get too attached to these, because in mathematics symbols are somewhat arbitrary. Although we try to be consistent with our use of symbols, they will change. And in the case of parabolas, once we move away from parabolas to a more generic type of graph, then h and k get disposed of, and we see them in other ways. The axis of symmetry, a vertical line passing through the vertex. You know, it might be useful for me to jump back and forth to a diagram here. So here we go. So the first thing is the vertex. The vertex is either the highest or lowest point on the parabola. So you can see in this case, this parabola opens downward. The opening is on the downward side, and it has a maximum. This blue parabola, it opens upward. The opening is on the upward side, and it has a minimum. Each of these 2 points that I've labeled here, these are known as vertices, or each one is the vertex. The axis of symmetry is a vertical line passing through the vertex, having the equation x equals h. Just to remind you, x equals h is the equation of a vertical line. Something you should have seen before, just to refresh your memory on that. So if I were to take a look, well, where's the axis of symmetry? It's the vertical line that goes through the vertex. So let's see, do I have a convenient line here? I guess I'm just going to have to settle for a generic dark line on both. So there is my axis of symmetry. So this is through the blue vertex. We have our axis of symmetry, and this would be the axis of symmetry. It looks like it goes through 2.5, or x equals 5 over 2 equals 2.5. Those are the same things. And then over here we've got our axis of symmetry, and this one is going to be through x equals -2. So those are the axis of symmetry. Axis of, sometimes we just abbreviate that A of S, the axis of symmetry. If the parabola opens up, the coefficient of the x squared is positive. We'll see that when we take a look at the equations. And when the parabola opens down, the coefficient of x squared is negative. These are things that I actually discussed in the previous video lesson as well. So if it opens up, I should have chosen the other color for that. If the parabola opens up, then what it's saying is the vertex is at the lowest point, so this is the minimum value. A new word that we might be introducing to your vocabulary here is optimum. The optimum value is either the minimum or the maximum, depending on the shape of the curve involved. So in the case of a very poorly drawn parabola opening down, in this case the optimum value is a maximum. whereas in the case of this blue parabola, because it opens up, the optimum value is a minimum. So it just depends on the shape. Okay, so moving on from there, we've got our two parabolas, or two examples. Obviously, there's an infinite number of different parabolas that you could have. Okay, so taking a look, we've actually done a little bit of this already. So taking a look at our two parabolas here, and I know these are very small. Hopefully you can see them. Hopefully the screen resolution is good enough for them. Can you deduce the following for each of them? The direction of opening. Well, this parabola, obviously the opening is on the downward side, so this direction of opening of this one is down. And is it a maximum or a minimum? Well, in this case, we see it is a maximum value. This is the highest point, and that occurs at 1. So this one is a maximum, and it is a maximum value of 1. The number of zeros. The number of zeros would be how many times does it pass through the x-axis. So if I just highlight the x-axis on this graph, how many times does my red graph pass through the x-axis? There's 1 and there's 2. So there are 2 zeros. This is just a count. The number of zeros, there are 2 zeros. Normally you would just write 2 here. I'm putting the word zeros in there just to be really clear. The axis of symmetry, that's something we talked about already. That is the vertical line that passes through the vertex. And we discovered before that was the equation of the line x is equal to -2. This is a line. So that means it must have an equation of a line. So please don't just put -2 here. You have to say x equals -2. The location of the vertex, that wants the x and y coordinates of the vertex. X is equal to -2, y is equal to 1. The location of the zeros. Sometimes you could refer to these as points, and that would be perfectly fine. So this would be the point -3, 0, -3, 0, and the other one is at 1, 0. But sometimes we just go ahead and we just say or, and we just say the zeros are located at -3 and 1. We only refer to the x coordinates because they're zeros. Implicit in zeros is the fact that y is equal to 0. So including these zeros can be considered to be redundant information. Your choice, just be careful about it. I do think there is a communication advantage to doing it the way I've said it in the red here, because when you get into things, you're going to be expressing things like the maximum here was 1. The number of zeros was 2. So you might want to do something to distinguish regular numbers from things that have other meaning on the graph. So for example, the equation of a line has to be in this form. These are obviously points when they're in that bracket notation. This is a point for the location of the vertex. The same thing applies down here for the y-intercept. What is the y-intercept? That is where this line crosses the y-axis. That occurs at 0, -3. Or you could say, again, because the y-intercept understands that x is equal to 0, so we could also just say that occurs at -3. I tell you about this even though my preference is to state it as I've shown you here in the red. I tell you about these alternatives because you may see them represented that way. They may be represented that way by other students, by other teachers. Even I'm sure, at times in moments of laziness or where I mentally trip up, I'll probably represent them that way. And I want you to understand it's still correct, but in going for the more correct representation, I think that it's clear to do numbers, equations of lines, and points very explicitly. Let's take a look at the blue graph. The direction of opening for this one, obviously the opening is on the upward side, so we just say it opens up. Is it a maximum or a minimum? This one, it opens up, which means it has a minimum, and its minimum in this case, well, actually, can't really see that very well, but if I had to guess, I would say it's of negative 2.25, which is negative 2 1/4 or negative 9/4. This would be one of those cases, if you represented that as negative 2.25, I would accept either of those. But understand that this is just an approximation. We can't tell the numbers that well from this graph. The number of zeros, this one has 2 zeros. And they are here as I'm labeling them. The axis of symmetry. Again, this one is just going to be an estimate. Now I have a bit of an advantage because I'm the one who created these graphs. So I actually know that my guess is actually correct, and in this case it's x equals negative 2.5. Sorry, I said negative, but it's not negative, it's positive 2.5. Or x equals 5/2 as a fraction. And again, I would accept, if you were going from the graph, unless it was on the scale, I would accept this as a non-repeating decimal. Location of the vertex, that's here. Make that a really big dot. This is the location of the vertex, and in this case it's going to be at negative 2.5 through the axis of symmetry. And again, why am I desiring to make this a negative? It's not a negative, it's positive 2.5. And the y-coordinate is the one that's negative on this. Let's go back. I feel like I need to rewind and reset that. Positive 2.5, and then the y-coordinate is negative 2.25. That's our estimate. And again, because I have a little bit of extra insight from creating this, that is actually correct. The location of the zeros in this case, 1, 0. Remember, the y-coordinate is equal to 0, and 4, 0. And then finally, where is the y-intercept on this graph? We have to scroll up. You can see it's way up here at x equals 0, y equals 4. X equals 0, y equals 4. Okay? All right. Now, when we talk about the zeros are actually something that we're very interested in when it comes to quadratic relationships or parabolas. Remember, I warned you, quite often we'll be talking about those interchangeably. When we talk about the graphs, we're talking about parabolas. When we talk about the equations in general, we're talking about quadratic relationships. So a parabola can have 2 zeros. So this parabola opens down and it has 2 zeros. This parabola opens up and it has 2 zeros. But I want you to imagine if we took this blue parabola and somehow we changed the equation in a way that caused the whole thing to shift down, down, down. Well, eventually these 2 zeros would get closer together. Eventually this line would shift down, and eventually this line would shift down, and eventually we get to the point where the vertex itself would be touching the x-axis. And so if that happened, we would get to the situation where we only have 1 0. So you can see I've done that using my graphing software. I've taken the red parabola and I shifted it up until only the vertex was touching. And I took my blue parabola and I shifted it down until only the vertex was touching. So now we only have 1 0 for each of these parabolas. And finally, if you kept shifting in those two different directions, so if you kept shifting the blue down, eventually it would shift past the x-axis. And since this graph carries on downwards, then there's no way for it to come up back here and touch the x-axis. The same thing is true. We have shifted the red parabola upwards, and since it continues upwards, there is no way for there to be any contact. So that's known as having no zeros. So you have that option. You could have two zeros in a parabola. I'll just focus on the red one. 2 zeros in the parabola, crosses the x-axis twice. You might hear that referred to as roots, and of course x-intercepts. Our definition for x-intercept, that's poorly written. The definition for an x-intercept stays the same, which is set y equal to 0. So x-intercepts, zeros, and roots are all interchangeable terms when it comes to parabolas. So that's 2, only 1, and finally 0. So last thing we're going to finish with, just a little exercise. Take a look at the 3 parabolas that I've got here. I've got blue solid, I've got a very finely dotted red line, and I've got a more widely dotted green line. And I've marked off some points on there. So the question is, what are the key features from these 3 graphs? So again, you can see I've got a small copy underneath here. I may have to shift it around so we can see some certain features. So let's start with the blue one. And here's the equation as well. A couple of things I want to talk about as they come up in the equation. So the vertex for the blue parabola is right here, and that looks to be at 2. Now be careful of the scale here. Notice that this scale goes to -2. Each square vertically is 2 units. Horizontally is 1 unit. So this actually would be at -1, which means this point, assuming that these are mostly on whole numbers, this vertex is actually at 2, -1. The direction of opening is up, and I want you to notice that the direction of opening ties into the coefficient in front of the x squared. It's a positive coefficient in front of the x squared. It's +1, and that gives me a direction of opening up. Same thing is true. Once I know the direction of opening, I know this is going to be a minimum at, and what is the, or it's not say at, let's say a minimum of, the minimum value of this is -1, which is the same as the y coordinate of the vertex. Oh, that's on my next line. So it is a minimum, and now the minimum value is -1, and that's from here. That's from the y coordinate of the vertex. The y-intercept, where does it touch the y-axis? Again, don't forget the scale. That's 2 and that's 4. Halfway in between is 3. So this is a point. So I'm going to say x equals 0, y equals 3. Where are the 0 or zeros? Remember that you could have 2 zeros, 1 0, or no zeros at all. In this case, they're already labeled for you. They are the points 1 0, 3 0. And the axis of symmetry, the vertical line that goes through the vertex here, and that is at an x coordinate of 2. So that is the vertical line, x equals 2. The next equation, the vertex of the red is at a y value of 4 and an x value of 0. So that is the point 0, 4. Direction of opening for this one is down, and we can get that from the graph of the parabola, but I want you to also notice the coefficient in front of the x squared is negative, and that also tells us that it's down. So that tells us if it opens down, that means that it's actually going to be a maximum. And what is that maximum value? The maximum value is 4. We got that from the y coordinate of the vertex. The y-intercept, well, it crosses the y-axis at the vertex, so that turns out to be the same point, 0, 4. The zeros themselves, x equals -2, so that's -2, 0, and +2, 0. And finally, the axis of symmetry. The axis of symmetry is this vertical line that is the y-axis. What is the equation of the y-axis? What is the defining property of the y-axis? It is when x is always equal to 0. Okay, I'll just put a little note there that that's the same as the y-axis, but we still have to use this equation notation. And then finally, our green parabola. I might have to shift things a little bit here to be able to see it. The vertex of this green parabola, actually that's very inconvenient, so that would be -7, -6.5. I think it's at, horizontally, it's at -3.5. And vertically, it looks like it's down here at -6.25. This is best guess, and to be honest with you, I don't even remember this one well enough to be sure, but we're going to put that, and we're going to say that's an approximation. And everything else that comes from there is also going to be an approximation. Direction of opening, that's not an approximation. It opens up, and that's coming from the fact that this is a positive number in front of the x squared. Is it a maximum or a minimum? It is a minimum. What is that value? It's our approximate -6.25. Where is the y-intercept? Does it appear on our graph? It does. It appears here at y equals 6. So that's the point. X equals 0, y equals 6. Zeros, this one has two zeros. -6, 0. This is the x-coordinate, the y-coordinate is 0, and -1, 0. In general, when you write your zeros, write them from left to right as they appear on the graph. So -6, 0, and -1, 0. If you go back and look at the red one, I did -2 and +2. On the blue one, I did 1 and 3. And on the green one, finally, the axis of symmetry, that's this vertical line. I'm just putting it in very roughly by hand. So it goes through, we are only interested in the x-coordinate of this one, and we think that that is at -3.5. So the axis of symmetry is x equals -3.5. These are all the equations of vertical lines. And I believe that's it. Just on to assigned work. Okay, so that was a look at the characteristics or key properties of a parabola.